Welcome. Today we will see problems on worm gears. Now this is the first problem. A pair of worm gears is designated as 1/30/10/8. Calculate center distance, the speed reduction, the dimensions of the worm and the dimensions of the worm wheel. Now we will see the solution. First of all, given quantities. Now given data is Z1 is equal to 1, Z2 is equal to 30 teeth, Q is equal to 10 and module M is equal to 8 mm. Therefore step 1 is nothing but center distance. Center distance small a is equal to 0.5 m into bracket Q plus Z2. Therefore substituting the values, a small a is equal to 0.5 into 8 into 10 plus 30. Therefore small a is equal to 160 mm. Now step second, speed reduction. Speed reduction I is equal to Z2 upon Z1. Therefore I is equal to 30 divided by 1, which therefore I is equal to 30. Now step 3, dimensions of worm. First of all, pitch circle diameter. Pitch circle diameter D1 is equal to Q into M, which is equal to 10 into 8. Therefore D1 is equal to 80 mm. Now outside diameter of worm, DA1 is equal to M into bracket Q plus 2. Therefore DA1 is equal to 8 into bracket 10 plus 2. Therefore DA1 is equal to 96 mm. Next, lead angle. Lead angle is given by tan gamma is equal to Z1 upon Q. Therefore tan gamma is equal to 1 divided by 10. Therefore gamma is equal to 5.71 degree. Now root diameter of the worm is given by df1 is equal to m into bracket Q plus 2 minus 44 cos gamma. Therefore df1 is equal to 8 into bracket 10 plus 2 minus 4.4 cos of 5.71. Therefore df1 is equal to 60.9747 mm. Now axial pitch, px is equal to pi into m, which is equal to pi into 8. Therefore px is equal to 25.1327 mm. Now step 4, dimensions of worm wheel. In that first is pitch circle diameter of the worm wheel. Therefore D2 is equal to M into Z2. Therefore D2 is equal to 8 into 30. Therefore D2 is equal to 240 mm. Throat diameter of the worm wheel. DA2 is given by DA2 is equal to M into bracket Z2 plus 4 cos gamma minus 2. Therefore DA2 is equal to 8 into bracket 30 plus 4 into cos of 5.71 degree minus 2. Therefore DA2 is equal to 255.84 mm. Now root diameter of the worm wheel. DF2 is equal to M into bracket Z2 minus 2 minus 0.4 cos gamma. Therefore DF2 is equal to 8 into bracket 30 minus 2 minus 0.4 cos of 5.71. Therefore DF2 is equal to 220.8159 mm. Now problem number second. A pair of worm and worm wheel is designated as 3/60/10/6. The worm is transmitting 5 kilowatt power at 1440 rpm to the worm wheel. The coefficient of friction is 0.1 and the normal pressure angle is 20 degree. Determine the components of the gear tooth force acting on the worm and the worm wheel. Now we will see its solution. These are the given quantities. Power kilowatt is equal to 5, n speed is equal to 1440 rpm, coefficient of friction mu is equal to 0.1, alpha pressure angle is equal to 20 degree, z1 is equal to 3, z2 is equal to 60 teeth, q is equal to 10 and m is equal to 6 mm. Step 1, components of tooth force acting on worm. In that, first of all we will find out d1 is equal to q into m. d1 means pitch circle diameter of the worm. Therefore d1 is equal to 10 into 6. Therefore d1 is equal to 60 mm. Now lead angle tan gamma is equal to z1 upon q, which is equal to 3 divided by 10. Therefore tan gamma is equal to 0.3. Therefore gamma is equal to 16.7 degree. Therefore torque transmitted is calculated by using this formula. Torque transmitted mt is equal to 60 into 10 raised to 6 into kilowatt divided by 2 pi n1. Therefore substituting the values, mt is equal to 60 into 10 raised to 6 into 5 divided by 2 pi into 1440. Therefore torque transmitted mt is equal to 33157.28 Newton mm. Therefore tangential force P1T is given by P1T is equal to 2 into mt divided by d1. Therefore substituting the values, 2 into 33,157.28 divided by 60. Therefore P1T we are getting it as 1105.24 Newton. Now axial or thrust force is given by P1A is equal to P1T into cos alpha into cos gamma minus mu sin gamma divided by cos alpha sin gamma plus mu cos gamma. Therefore substituting the values, 1105.24 into cos of 20 into sin of 16.7 minus 0.1 into sin of 16.7 divided by cos of 20 into sin of 16.7 plus 0.1 into cos of 16.7. Therefore we are getting it as P1A is equal to 2632.55 Newton. Now radial force P1R is given by P1R is equal to P1T into sin alpha divided by cos alpha into sin gamma plus mu cos gamma, which is equal to substituting the values, which is P1R is equal to 1105.24 into sin 20 divided by cos 20 into sin 16.7 plus 0.1 into cos of 16.7. Therefore by calculation P1R is equal to 1033.35 Newton. Step 2, components of tooth force acting on worm wheel. The force components acting on the worm wheel are as follows. P2T is equal to P1A is equal to 2632.55 Newton. P2A is equal to P1T is equal to 1105.24 Newton. P2R is equal to P1R is equal to 1033.35 Newton. Now problem number 3. 1 kilowatt power at 720 rpm is supplied to the worm shaft. The number of starts for threads of the worm is 4 with a 50 mm pitch circle diameter. The worm wheel has 30 teeth with 5 mm module. The normal pressure angle is 20 degree. Calculate the efficiency of the worm gear drive and the power lost in friction. Coefficient of friction mu is equal to 0.035. Now we will see the solution. These are the given quantities. Kilowatt is equal to 1, rpm small n is equal to 720 rpm, pressure angle alpha is equal to 20 degree, d1 is equal to 50 mm, z1 is equal to 4, z2 is equal to 30 teeth and module m is equal to 5 mm. Now step 1, efficiency of worm getter. Therefore we will first of all find out value of Q. Therefore value of Q we will find out by using this equation, that is d1 is equal to qm. Therefore Q is equal to d1 upon m. Therefore Q is equal to 50 divided by 5. Therefore Q is equal to 10. Q means diametral quotient. Therefore lead angle is given by tan gamma is equal to z1 upon q, which is equal to 4 divided by 10, which is equal to 0.4. Therefore gamma is equal to 21.8 degree. Therefore efficiency is given by, efficiency is equal to cos alpha minus mu tan gamma divided by cos alpha plus mu quad gamma. Therefore substituting the values, cos 20 minus 0.035 into tan of 21.8 divided by cos 20 plus 0.035 into cot of 21.8. Therefore we are getting efficiency is equal to 0.9012. Therefore step 2, that is power lost in friction. Power lost in friction is given by, power lost in friction is equal to 1 minus efficiency into kilowatt, which is equal to 1 minus 0.9012 into 1. Therefore which is equal to 0.0988 kilowatt or 98.8 watt. Now problem number 4. A pair of worm and worm wheel is designated as 130 10 10. The input speed of the worm is 1200 rpm. The worm wheel is made of centrifugally cast phosphor bronze and the worm is made of case hardened carbon steel 14C6. Determine the power transmitting capacity based on the beam strength. Some values are given in the problem, that is SB1 is equal to 28.2, SB2 is equal to 7.0, XB1 is equal to 0.25, XB2 is equal to 0.48. Therefore we will see the solution. These are the given quantities. N1 is equal to 1200 rpm, Z1 is equal to 1, Z2 is equal to 30 teeth, Q is diameter quotient is equal to 10, M is equal to module which is equal to 10 mm. Therefore step 1, permissible torque on worm wheel. We have to find out first of all permissible torque on the worm wheel, and then we will find out power transmitting capacity. In that, first we have to find out speed ratio I is equal to Z2 upon Z1. Therefore I is equal to 30 divided by 1. Therefore I is equal to 30. We know that I is equal to N1 upon N2. Therefore N2 is equal to N1 divided by I, which is equal to 1200 divided by 30. Therefore N2 is equal to 40 rpm. Now pitch circle diameter of the worm wheel is given by D2 is equal to M into Z2, which is equal to 10 into 30 is equal to D2 is equal to 300 mm. Now lead angle is given by tan gamma is equal to Z1 upon Q. Therefore 1 divided by 10. Therefore gamma is equal to 5.71 degree. Effective face width of worm wheel teeth is given by F is equal to 2m into square root of Q plus 1. Therefore substituting the values, F is equal to 2 into 10 into square root of 10 plus 1. Therefore F we are getting it as 66.33 mm. Therefore clearance C is given by C is equal to 0.2 m cos gamma. Substituting the values, C is equal to 0.2 into 10 into cos of 5.71 degree. Therefore clearance C is equal to 1.99 mm. Now outer diameter of the worm is given by dA1 is equal to m into bracket Q plus 2. Substituting the values, therefore dA1 is equal to 10 into bracket 10 plus 2. Therefore dA1 is equal to 120 mm. Length of the root of the worm wheel teeth is given by LR is equal to dA1 plus 2C into sine inverse of F divided by dA1 plus 2C. Therefore, substituting the values, LR is equal to 120 plus 2 into 1.99 into sine inverse of 66.33 divided by 120 plus 2 into 1.99. Therefore, LR we are getting it as 69.988 mm. Therefore, torque transmitted is given by MT1 is equal to 17.65 into XB1 into SB1 into M into LR into D2 cos gamma. Therefore, substituting the values, MT1 is equal to 17.65 into 0.25 into 28.2 into 10 into 69.988 into 300 into cos of 5.71. Therefore, MT1 is equal to 25,996.711 Newton mm, that is A. Similarly, MT2 is given by 17.65 into XB2 into SB2 into M into LR into D2 cos gamma. Therefore, substituting the values, 17.65 into 0.48 into 7 into 10 into 69.998 into 300 into cos of 5.71. Therefore, MT2 is equal to 12,389.922 Newton mm, that is B. Comparing A and B, we are getting as the lower value of the torque on the worm wheel is 12,389.922 Newton mm. Therefore, step 2, power transmitting capacity based on beam strength is given by kilowatt is equal to 2 pi into mt divided by 60 into 10 raised to 6. Therefore, 2 pi into 40 into 12,389.922 divided by 60 into 10 raised to 6. Therefore, kilowatt we are getting it as 51.9. Now, problem number 5. A worm gearbox with an effective surface area of 1.5 meter square is operating in still air with a heat transfer coefficient of 15 watt per meter square degree Celsius. The temperature rise of the lubricating oil above the atmospheric temperature is limited to 50 degrees Celsius. The worm gears are designated as 1/30/10/8. The worm shaft is rotating at 1440 rpm and the normal pressure angle is 20 degree. Calculate the power transmitting capacity based on the thermal considerations. Now we will see the solution. These are the given quantities. Area A is equal to 1.5 meter square. Heat transfer coefficient K is equal to 15 watt per meter square degree Celsius. Temperature difference T minus T naught is equal to 50 degree Celsius. Z1 is equal to 1, Z2 is equal to 30 teeth, Q is equal to 10, M is equal to 8 mm, small n is equal to 1440 rpm, and coefficient of friction mu is equal to 0.024. Therefore, step 1, efficiency of worm gear drive we will calculate. In that, first of all, we will calculate lead angle. Lead angle tan gamma is equal to Z1 upon Q, which is equal to 1 divided by 10. Therefore, gamma is equal to 5.71 degree. Now, pitch circle diameter of worm is given by D1 is equal to M into Q. Therefore, D1 is equal to 8 into 10. Therefore, D1 is equal to 80 mm. Therefore, efficiency of worm gears is given by efficiency is equal to cos alpha minus mu tan gamma divided by cos alpha plus mu cot gamma. Therefore, substituting the values, efficiency is equal to cos of 20 minus 0.024 into 0.1 divided by cos of 20 plus 0.024 divided by 0.1. Therefore, efficiency we are getting it as 0.7945. Now, step 2, power transmitting capacity based on thermal considerations. Therefore kilowatt is given by K into T minus T naught into A divided by 1000 into bracket 1 minus efficiency. Therefore substituting the values, kilowatt is equal to 15 into 50 into 1.5 divided by 1000 into bracket 1 minus 0.7945. Therefore by calculation we are getting kilowatt is equal to 5.47. Therefore these are the